Hey guys, sorry I'm not there on the first day that you're starting this TORC project, but my mom, who watches my children while I work, is sick, so I'm home with my kids. So this video is going to kind of walk you through this TORC project, kind of like I was there and what I would be doing, but you have the guidelines and you have the rubric. If you don't, you need to ask the teacher that's in there for those two handouts, and you need to read through them very carefully so that you can get all the points. In this TORC project, you're creating a mobile. The mobile is supposed to be balanced. So we're going to talk about how you balance something. Now, a couple class periods ago, we talked about the torque equation that was force times the radius. And the force is the amount of force that's there, and then the radius was basically the distance from the fulcrum to the weight. So I'm going to kind of show you what that means here. And we're going to use an example of a seesaw. And this is the fulcrum right here, right in the middle. Now, as a mom, I would love to take my kids and go, on a seesaw with them. So here I am. Now, we need my force, my weight. And you have to remember that to get weight, which is Fg, and Fg was equal to mass times gravity. So I'm just rewriting them two different ways because I know some of us are still a little confused that Fg is not 9.8. Fg is equal to mass times 9.8. So for me, I would need to know my mass in kilograms. So guys, I can't stress enough that when you're measuring back today in the lab, our balances only measure grams, which means you have to convert everything you do to kilograms. And to convert from grams to kilograms, you divide by 1,000. And that's right. I know I hesitated there, but that is right. The numbers should be getting smaller, and that's because kilograms is a bigger unit of measurement, so it's going to be a smaller number overall. So let's just say that my weight was, 100 newtons. I have no idea if that's realistic or not right now. So let's say I had a weight of 100 newtons, and my distance from the fulcrum, let's say, is 0.5 meters. Now your distances need to be in meters. So as you are doing this project, you're probably measuring in centimeters because we're measuring smaller sticks, so you're going to have to convert. From centimeters to meters, you divide by 100. So what I want to know is, if I place my daughter somewhere on this seesaw, and my daughter is, let's say she's 40 newtons. Okay, so here's my daughter. Hi, Genevieve. She's 40 newtons. Where on here would I place her so that everything is balanced? So what you have to do is just look at it from the left side to the right side. So right now, right here, that was a really bad line. Right here, to the right of this, you have me, that's 100 newtons, and you have me at a distance of 0.5. That's my force, 100, and my radius, 0.5. So this has to equal this side. And I know that I have a force of 40 newtons, but I'm not really sure what my distance is going to be, so that's kind of my x right here. So basically what you're saying is that the force on this side times the r on this side has to equal the force on this side times the r on this side. So I'm going to plug in my force of 40 for my daughter. I'm going to leave r there, and I'm going to set that equal to my force, which was 100, times my radius, which was 0.5. So when you solve this, 100 times 0.5, this side equals 50, and then this side I still have 40 times r, so I'm going to divide both sides by 40. 50 divided by 40 is 1.25. That means that my r for the left-hand side where my daughter is has to be 1.25 meters away. So she's a little bit more than double. So if she were to be placed on here, she'd need to be placed, somewhere out here. oh, she's floating in the air. Totally not what I meant to do, but that's okay. And so that distance would need to be 1.25 meters. If you do that, then the seesaw would be perfectly balanced. And notice that she's a little bit further away from me because she weighs less than me. So this is how you kind of create a balanced system. Now, in your mobile project, that's what you're going to be doing level by level. So I'm going to kind of just create an example, and we're going to walk through that. Okay, so in this part of the video, I'm going to kind of walk you through the process that you're going to do in your Torque Mobile. So you're going to have a string hanging it from the ceiling, and you're going to have something that's creating that first level. And then you're going to have string coming off of it, and you need a second level. Now your second level could be on either side, doesn't matter. My second level is just going here. And string coming off of that. You do need a third level. You have to have 3 levels. So here's my example. Now I have objects hanging from each one, whatever they may be. Before you can begin, you have to go get the mass of these, and you need to calculate weight. Remember that weight is equal to the mass in kilograms. Make sure you convert, times gravity, which is 9.8. And once you get the weight on your drawing, which may look just like mine right now because it's a rough draft, you need to record those weights. So I'm going to make some weights up here. I'm going to say this one is 17 newtons, this one's 8 newtons, 4 newtons, 2 newtons. Okay, totally made those up, but you need to calculate all of yours. Now, when you're trying to figure out how far away all these things are hanging, you have to just pick a number for one side, and then you calculate the other one. So, in your mobiles, it needs to have 3 levels. The blue one is my first, then the red one, then the green one. I'm going to choose for my 17 Newton weight here, I'm going to choose that it is 0.3 meters, because your distances need to be in meters. And we need to figure out what this distance is going to be to balance that out. Now, the part that's hanging off of this lever right here is actually all 3 of those weights, 2, 4, and 8, because they all go up into that string. And that's a total of 14 newtons. 2 plus 4 plus 8 is 14 newtons. So I'm just going to put like a little note to myself right here that I really have 14 newtons. Okay, so right now, you know, I got a little bit less on the left side than I do the right side. So to calculate this, you are going to take your distance times your weight. So 0.3 times 17. And 0.3 times 17 is 5.1. And that means your torque on this side is 5.1. And I need to have the same torque on the other side. So 14 times x needs to equal that 5.1. So 14 times x equals 5.1. Divide both sides by 14. And you get 0.36. Okay, so that means that right here, instead of putting my x, I can't get it to erase. Okay, too much time spent on that. 0.36 meters away. So when I go to hang it, I need to make sure that I measure that. And this makes a little sense because it weighs less, it needs to be a little bit further away. Okay, now we're going to move on to the red one. Well, I'm going to choose that my 8 one is going to be 0.25 meters away. Now be careful because there is a maximum size that you can have here, so be very careful. So I'm going to say this one is 0.25 meters, and we need to figure out what this one is. Well, the 2 and the 4 are both hanging, so I really have 6 newtons hanging off of this one. So this side, 8 times 0.25 equals 2, so that means my torque right here is 2, and I need 6 times something to also equal 2. So 6 times x equals 2, divide both sides by 6, and you get that the distance needs to be 0.33333, and no trial and error, 0.33 meters. Okay, and now, last but not least, my level 3, have a 4 and a 2. I'm going to randomly choose that this one's 0.1 meters away. And then I need to calculate this one. So 4 times 0.1 is 0.4. So 2 times x has to equal that 0.4. Divide both sides by 2, and you get 0.2. So that means this distance right here needs to be 0.2 meters away. Now, I don't have the rubric in front of me, so I don't know the overall dimensions. So I can't tell you whether this right here would fit in that overall dimensions. But if it doesn't, you have to go back and change your distances and recalculate and figure out how to hang this so that it will fit within those size constraints. So today, as you're working through this, there's some things that you need to get done for me. Now, Coach Sands probably has some stuff written on the board. It may help you. It may be less than what I'm putting. It may be more. Look at both of them and make your best judgment. But I'm going to switch to a new slide right here, and I'm going to go through this for today. It may have cut me off, but we're going to create a to-do list here. Okay, so number 1 is you need to mass your objects and convert to kilograms. Watch the beginning of the video if you don't remember how to do that. Number 2, you need to calculate the weight for your objects. Remember, that is mass in kilograms times gravity, which is 9.8. Number 3, you're going to do a rough drawing. This rough drawing does not need to be perfect. Do not spend your time making this one pretty. You're going to do that later. Okay, so your rough drawing could look just like the one I just did for you. But what it needs to have on it is distances, and it needs to have weights, along with anything else on that rubric, but for now, this is probably fine. Once you have that done, if you want me to check your calculations, put a comment on Google Classroom. Do it today during class. I'm at home. We're all semi-healthy. I'm just watching my own kids because my daycare provider can't, which is my mom. So I'll be checking. So send me an email or put it on Google Classroom and I can check it and let you know any feedback. If it's good, or if you feel confident with it, then I want you to do that final draft. But this one has to be to scale. So if you look on the rubric, it says that one box on the graph paper is 5 centimeters. So you need to kind of draw this to scale. I'm not so worried about the string being to scale, but I am worried about the, so not the string, but this part. Not the string. This part right here. The horizontal parts. There we go. Those need to be drawn to scale. And on your final draft, it's supposed to be in ink. You know, if all you have is pencil, I'll deal with it. I'm not there today. But on that final draft, you're supposed to have your distances, your weights, and anything else on that rubric. If you finish all of that, you can start putting it together. But this needs to be done first. Good luck, guys. And again, shoot me an email or put a comment on Google Classroom if you need help.